Hey pre-calculus friends, the law of sines, section 5-6. Let's get started. So for most of this chapter, we've been hanging out in kind of like right triangle land, right? So everything we've been doing, even the unit circle, had to do with a right triangle. The law of sines is going to give us an opportunity to deal with any triangle. And so we don't necessarily have to be dealing with the right triangle. And when we talk about this generic triangle, we're going to call the angles ABC and the sides opposite them lowercase a, lowercase b, and lowercase c in accordance with the angle names. And then so what the law of sines gives us is this relationship. It says that let triangle ABC be any triangle such that A, B, and C represents a measure of the opposite sides of the angles A, B, and C, like I just said. And then the following is true. Side A over the sine of A is equal to side B divided by the sine of angle B is equal to side C divided by the sine of angle C. Pretty powerful stuff. So that's a really nice law that we're going to use. And then from that law, we can get these other two laws. And so that first law, the law of sines, super easy to memorize. These area of a triangle laws, not so much, but we're going to be applying them during the lesson. So instead of reading them out, I think really the application, maybe copy them down in your notes, but really the application is going to be important. So we're dealing with that same triangle where we've got angles being A, B, and C, vertices being A, B, and C, and then the opposite sides being A, B, and C respectively. And then we have these relationships. So depending on the reason why we have so many formulas, it depends on what you're given to be able to determine the area of the triangle. So if you're given side B and you're given side A and you have side B and side C, but you have angle A, then you can find the area of the triangle. And so looking at it, let's go ahead and take a quick look. So for instance, if you have side B and side C, and you know side A, angle A. So if you notice that the given information has an included angle, so side B, side C, and A, then you can find the area. Let me use a different highlighter to demonstrate the other ones. If you have side A and side B, and then the included angle side C, and finally you guess what the other one is going to look like if you have side A and side C and the included angle B. So this refers to these three really are all the same formula that basically give us the area of a triangle if I have two sides in the included angle. Let's go ahead and apply that same logic to the next formula. So looking down here, what you notice is that you need all three angles for each of these, ABC, ABC, ABC. But what this formula does is if you have all three angles and just one side, let's say side A, then you can find the area of the triangle. And then we can go ahead and see that all three sides inside C, all three sides inside B. So really, even though there looks like a plethora of formulas, there's really only two for, or two in these two theorems. All right, let's go ahead and get started with some examples. Example 1, we're going to solve this triangle, and we remember that solving a triangle means finding all the information about it, the angles and the sides. So solve the triangle if angle A is 33, angle B is 105, and the side opposite angle B is 37.9. Okay, so I like to write a chart like this whenever we're solving a triangle. And the first thing I did was solve for angle C just because it's so easy to do, recognizing that the sum of all the angles in a triangle would be 180 degrees. So now we're going to get to the core of it. So what we need to do is make sure when we're dealing with the law of sines, and I'll write that down right here. So there we go with the law of sines. By the way, I hope you guys are thinking that even the reciprocal of this has to be true, which it is true. So if you find yourself not wanting to put the sides on top or wanting to put the angles, the signs of the angles on top, it's still true. The reciprocal of that is true. Okay, so let's get started. So we've got the little formula here, and you know, as usual, we've got to use what we've got to get what we want. So I'm going to start off with a 37 5.9 over the sine of 105, and that's going to be equal to, so I need A and I need C, so let me start off looking for A. It's going to be equal to A over the sine of 33 degrees. You know how I like to do this? I like to make sure that when I'm done, all I have to do is make everything calculator ready. So I'm going to solve for A. When I do so, A is equal to the sine of 33 degrees times 37.9 divided by the sine of 105 degrees. And since I'm in the market to do that, you guys understand that I can do exactly the same thing for C, right? So I would be setting up literally a similar proportion where C is at the top, and this time the sine of 42 is at the bottom. So if I take my hint from when I solved for A, solving for C would be similar, and I'd get that C is equal to the sine of 42 times 37.9. You guys with me? All of that over the sine of 105. And so now everything's calculator ready. I'm just going to go plug it into the calculator to get my values for A and C so I can have this triangle completely solved. So I've gotten these two answers with my calculator, and I like to look to make sure it makes sense. So for A, I have 21.37 approximately. And for C, I have 26.25. And it makes a certain sort of sense because I know that, well, I can just look here. This angle is smaller than this angle, 42 degrees, and therefore the side across from it should be the same, smaller than the other side across from it. So I'm feeling confident and I'm moving on. So let's go ahead and look at this next example. This example refers to information given earlier in the chapter, but we're going to look at the picture and see if we can divine the answer for ourselves. So how far is the fan from home plate? So this is the distance that we're looking for. Here's a fan up in the stands, and here's home plate, and let's see what information we can divine. But first, I'm going to change all of these degree measures from, and I think this is just helpful, the degree minutes to just the degree. So let's do that. So that change, you know how we do it. We take the minutes, we divide it by 60, and we add it as that to the original angle to get the angles just in the degrees that we're used to. And so now what we need to do is find this length here. What I'm observing, and I think you are too, is that we do have a triangular relationship, right? So we know that the law of sines can be used when we have any type of triangle. So the greatest thing here, or the best idea that I have, is to see if we can use the law of sines. Law of sines requires that we have one angle and then the side opposite it, which I think we can get. Let's see if we can determine what this angle theta is. We know that this entire angle here is 29.9 degrees, and we know that this little bit here is 24.12. We're assuming that this is the horizontal line kind of towards the horizon, and so what we're going to do is subtract 24.2 from 29.9 to get theta. So what I'm getting when I do that subtraction is that the degree measure there is 5.7 degrees. And so if that's 5.7 degrees, now I've got the relationship that I want. Sine of one over the length of the other is going to be equal to the sine of this one over the length of this one. You guys seeing what I'm talking about? Let me do a little bit of a color coding here. So what I'm noticing is this relationship here with this guy is going to help us with this relationship here and this guy here. I don't know. You get what I'm saying. All right, good. So let's go ahead and do this anyway. The setup using law of sines, d over sine of 24.2 degrees is equal to 60.5 times the sine of 5.7 degrees. And so, you know, I like to make a calculator ready. So here we are, calculator ready, and we get that the distance from the fan to home plate is 249.7 feet. Here in example 3, we're going to use one of the formulas to find the area of a triangle given the information that we have. So you see that this is the one that we talked about earlier, where we're given two sides and the included angle. And if we scroll back up to where we were earlier, Within our notes, we'll see that this formula is the one that we want to use, where we take the 1/2, the length of the two sides, times the sine of the included angle. So let's get back to our problem, noting that the area is going to be equal to 1/2 A times C times the sine of angle B. So 1/2 the product of these two sides times this included side. So really it's just a matter of making sure we can make everything, calculator ready. And so we're going to take this 47 degrees and 20 seconds and turn it into just straight up degrees. So that's going to be 47 plus 20 over 60, right? And so that's really just going to be 1/3 or 3 repeating. So 47.3 repeating degrees is what we're dealing with here at angle B. And then so we have 1/2 times 4.7 times 12.4 times 4 times the sine of this angle. And so again, I'm just going to go over to our calculator and get the area in just a second. And with that, we get 21.43 units squared. I don't think they told us if they were feet or inches, so we'll just do units squared because we're dealing with area. Let's look at another example. So here in example 4, we're going to find the area of this triangle DEF, and we're given some information. What we are given is the measure of this angle, the measure of this angle, and technically we're also given the measure of this angle, which is 130.8, and that's if we subtract all of this from 180. So we're given the measure of all three angles, and we have one side. And we knew that this information can lead to the area of a triangle, given some information that we had at the beginning of the chapter, right? When we took our notes earlier, what we saw was that there were two ways to find the area of a triangle given the sides and angles, and the other way, given all the angles and one side, was to take 1/2 of the, actually I think 1/2 of the square of the side that you're given, and then you're going to take the product of the sine of both of the other angles that has nothing to do with that side, and then divide by the sine of that angle that is related to that side. I hope that made sense, but glance at all of these. You'll see that since the side we're given here is B, that the sine of B is in the denominator, and since the side that we're given here is C, then the sine of C is in the denominator. So let's take that back to the problem we were just working on. So we have 1/2 the side squared, that's 13.9 squared, and since that's related to angle D, we're going to put the sine of angle D in the denominator. That makes sense, you guys? You see what we were talking about? Instead of like memorizing every angle possibility, look at the relationship and see if that works out. Okay, so sine of 14.8 times the sine of this other angle not related to side D, which is 130.8. And now we have a calculator ready, and I'm just going to plug the information into our calculator to get the area. So we get 33.06 units squared. So that's it for this lesson. I'm hoping that this made sense. Let me know if it did not. And of course, I look forward to talking to you soon. Take care, guys.